So what's wrong with this calculation? We have 14.5 centimeters times 3.07 centimeters divided by 6.3 flowers. Don't worry about the units. And then I have 7.0658730158730016 centimeters squared per flower. Pause the video right now for a second and try and figure out or decide what's wrong with presenting this. Hopefully, you realize that we're not doing significant digits in the answer. Most importantly, we can't possibly know the answer to this depth if this is the only depth we know for the actual numbers we're using to calculate. If we only have 14.5, not 14.500000, then we can't say we know the answer to this kind of accuracy, precision. Another example of this, if you look at down here, and I'm not going to dwell on this one, but what I've done is I've taken 14.5 and said it could be anything from 14.46 to 14.54, rounded to 14.5. So I took the two extremes there, and the same thing with the other two numbers. I took the extremes that would give me the widest possible range of values. And there's no way we can know. The best we can know this to is maybe one decimal place, 7.1, 7.0, maybe. So that's the key point for significant digits, the reason why we have to communicate this information when we do calculations. Welcome to the third video tutorial for physics, grade 11 physics. I know I called it 1, I don't care. Video tutorial number 3. And this one's on significant digits and the rounding involved in presenting numbers to significant digits. So this is going to be a good slide to pause on. It's kind of busy, but before you do, just a quick run through. Some key points when we're doing significant digits. The first thing you have to do when you're given a problem in physics is to read the question and figure out from the question how many significant digits should probably be in the answer. Sometimes there will be information in there you didn't use, so you don't use that digit to decide. The point, we'll get into some details later, but the point is, at the very beginning of the problem, decide that, put a little number underneath where you're going to write your answer so you remember to check at the end. Second point, the most common challenge in sig digs is the zeros. Often you're going to have zeros presented to you as part of a question, and you have to decide which zeros matter. And the key question there, the key points here are covered in this chart off to the right, which I want you to take a look at. The first column is where the textbook talks what the textbook says in around page 650 in appendix A6. Right here, I've reworded it my own way to hopefully give you another understanding, another level of understanding, and then I've got a couple of examples. Finally, when you communicate your answer, when you write your answer, you have to communicate the number of significant digits in the way you write your answer. Not by saying to 3 sig digs, but actually writing 3 digits in your answer. So remember to do that. These are worth communication marks on tests and quizzes. So have a quick look at this. This is when you want to pause and have a look at this chart and try and get an understanding. We will spend a little bit of time on this in class, and of course you'll be doing it all semester. So have a look at this. Tell me the next day. This is my way of checking that people are actually watching my video. All right, when we're going to round, we round in 2 basic rules, simple rules you have to remember. The first rule is the majority of the rounding you're going to do. What you're going to say is you're going to have a set of digits. You're going to have a number to which you have to round it. So we're going to use 4 decimal places here, or 4 digits here. So 1, 3, 8, and something. Now we have to decide which number this is going to be. If this number here, the next number over that you haven't discarded yet, but you're going to, in other words, the first number you're going to discard, if it's 1, 2, 3, or 4, in this case, of course, it's a 4. If it's a 4, 3, 2, or 1, then you're going to round down. In other words, 74501 is closer to 7 than it is to 8. So we're going to call this 1.387. So that's the first one. 1, 2, 3, and 4 on the first discarded number, round down. The next rule, so that's the first one, the next rule is 6, 7, 8, and 9, round up. So in the second example here, we're going to take 3 significant digits. So we're going to take these 3 places and not afterwards. Well, the next digit is a 7. That's the first one we're going to discard. It's higher than 5, So it's closer to 1.39 than 1.38, so we're going to write 1.39 as our answer. Finally, if it's a 5, but there are digits afterwards, non-zero digits afterwards, so 501 is the example here, then you round up because, again, 5 digits will take us out to the 4. This is 501. Well, 501 is closer to 75 than it is to 74. It's closer to the higher number. So if there are any digits afterwards, we round upwards. So this one's going to be 1.3875. So that takes care of the first rule. The second rule is when we are exactly in between the two possible values. When our final discarded digit is a 5 and it's all zeros afterwards, then it's exactly halfway between. When you've got that, you need to round to the even number. So in this case, the first example, 1, 2, 3, 4, 5, we're rounding to the 4, and there's a 5, 0 afterwards, so we're going to round to the even number. This is exactly halfway in between. We needed a rule to make tiebreakers, so we round to even. So 1.3874. Second example, 5 digits takes us to the 3, and it's a 5, 0, so again, tiebreaker, and every time when it's in exactly 5, exactly in between, we round to the even number. So this one will also round to 1.3874. And I can talk about that in class. There's a statistical reason for doing that. Finally, a couple of examples. Pause the video now and try all of these on your own. So hopefully you've read the information in the basic stuff handout. There are 2 different rules for significant digits. If you're doing just adding and subtracting, then you take the number of digits after the decimal place. The smallest one decides what your answer is going to have. So for the first example, 2.301 has 3 numbers after the decimal place. 1.4444 has 4. The smallest of those 2 numbers is 3, so our answer has to have 3. Now this one comes out to 3 point. 3 and 4 is 7. 0 and 4 is 4. 1 and 4 is 5. And then there's a 4 afterwards. So 3 digits after the decimal takes us here, so the answer is going to be 3.745. Excuse me. Same rule is going to apply over here. 2 digits after the decimal place, 1 digit after the decimal place, so our answer is going to have 1, the smallest of those numbers. 321.66, 321 plus 21 is 342. 0.6 plus 0.1, so 0.7, and then there's another 6 afterwards from this first number. So again, one value after the decimal place, this is going to be 342, and then the 7 is going to round up because of that 6 to 8. Now the rule with multiplication is the number of digits in the value determine the number of significant digits, not after the decimal, but all of them. So in this case, we have 1.2, that's 2 significant digits. 3.33 is 3, so this one is going to decide. When we multiply that out, we're going to have 2 significant digits. Okay, so I've magically tossed in a couple of answers here to save time on calculation. So right here we have 2 significant digits, so this has to round to 2 significant digits. Well, 3.99, that's going to round us upwards, which is going to take us to 4.0. And that's meters for the units. Remember to put the units in at the end. This one here doesn't have units, so we're fine with that, but this comes out to a repeating decimal place, 0.33333, and so on. However, 1 significant digit, 6 significant digits, so the 1 makes the decision. The answer is 0.3. Part E comes out when we divide this. This is a divided sign, by the way. 6.3 divided by 2.34. I only put 4 decimals in there because I know that this is 2 sig digs, this is 3 sig digs, so we need 2. 2.69 comes out to 2.7. And that's going to be meters per second. Do the same thing with the units that you would with algebra. Last question. When you have a question like this, you need to put them all in the same unit. Centimeters, meters, and millimeters are different, so we have to convert. You can practice, you can do some conversion on your own. I'll show you how this one comes out. 6.743 meters, and then 2.554 meters. and then 1.583.34 meters. So, do the calculation really. 2.60566 is what I get. Let's get rid of that decimal, that's not supposed to be there. And that is in meters. And here we have only adding and subtracting. It's only subtracting. So this has 3 decimal digits after the decimal, 3 and 5. So 3 is going to be the answer. So 2.60, and then the 5 becomes a 6 because of the 6 afterwards. All right, that's it. Fill in the rest of what your handout as you can, and we can talk about it in class tomorrow. Remember to do the test question from the other slide right here. Have a good night.